Let's begin. Hello everybody. Let's see. Let's start. Let us start. हमारा टीवी बंद है हाँ यही रहा. Let's begin the lecture. आप have you revised the last lecture? Good evening everybody. Have you revised the last lecture? Today we will see a second part of Atterberg limit. In the last lecture I had talked about liquid limit. In today's lecture I will talk about plastic limit as well as the shrinkage limit in detail. Okay. Okay, sound is low. No. From my side, sound is perfectly fine, beta. You can increase your levels, please. Sound is perfect from my side. I can see it's pretty much audible. Please increase the sound from your side as well. Okay, let's start. What I was saying here, my pen I am not getting. Give me a moment, please. I will start. Yeah, I got my pen. Yeah. So today I will start with Atterberg limit part 2. In the last class we have talked about the liquid limit. In today's class I will be mostly talking about the plastic limit as well as the shrinkage limit in detail. Let's begin our discussion. So what is plastic limit, my dear friends? What is plastic limit? Tell me fast. What is plastic limit? So plastic limit we already know it is the boundary moisture content between the semi-solid and the plastic state. You remember in the last class we have seen this graph between water content and, you remember in the last lecture we have seen this graph between volume as well as the water content. This is solid state, semi-solid, plastic, and finally we have the liquid condition. This was shrinkage limit, this is plastic limit, and this is liquid limit. Liquid limit we have already seen. Today I will show you what is plastic limit as well as shrinkage limit. So plastic limit is nothing but the boundary moisture content between the semi-solid as well as the plastic condition. How you determine this plastic limit? Here we do a simple lab test, that is also known as the thread test. What you do is we make a soil sample. We make a soil sample. What do we do here is we will make a soil sample. We simply make a soil sample here. Okay. So we make a soil sample here. Wait a minute, my lights are not working properly today. Okay. Okay. Yeah. Perfect. So we make a soil paste out of the soil sample. We add water inside the soil to make a soil paste, and then we try to roll the soil into a thread of dia 3 mm. If we are able to roll the soil into a thread of dia 3 mm, means plastic limit is not reached yet. Now what you will do, you will dry the soil. Not completely dry, you will dry a bit, means you will ensure that it is still a soil paste, but you will remove some water by drying. Then again you will roll the soil into a thread of dia 3 mm. If you are able to roll it into dia 3 mm, again plastic limit is not reached, you will again dry the soil. Like this you will reach a water content at which when you roll the soil into a thread of dia 3 mm, it starts to crumble, means you will see cracks on the thread. That is my plastic limit. So plastic limit is the moisture content at which when soil when rolled into a thread of dia 3 mm starts to crumble. Means if you dry the soil beyond this moisture content, you will not be able to roll it into a thread of dia 3 mm. So plastic limit moisture content is a moisture content such that when soil, when rolled into a thread of dia 3 mm, starts to crumble, there will be visible cracks on the soil surface. So this is how plastic limit is defined. And obviously the shear strength of plastic limit, shear strength of soil at plastic limit is more than that at the liquid limit. It is seen that shear strength of soil at plastic limit is approximately 100 times more than that at the liquid limit. This is all written. So it is the boundary moisture content between plastic state and semi-solid state. It is determined using plastic limit test or thread test. At plastic limit WP, soil when rolled into a thread of diameter 3 mm starts to crumble. Approximately the shear strength of soil at plastic limit is 100 times more than that at the liquid limit. Got my point, Mr. Akash? Am I audible now? Is it okay now? Mr. Akash, I guess you have corrected your earphones or whatever speakers you are using. Okay? No, this is not a crash course. This is actually not a crash course. We are just trying to make clear the basics of geotechnical engineering so that you develop an interest for this topic. This is not a crash course, please. And the total syllabus will not be covered here. Only few important topics I am covering that will help you inculcate interest into the topic. Okay. Anyways, let's proceed further. Then next is shrinkage limit. Now we already know what is shrinkage limit. Shrinkage limit is the boundary moisture content between what state? Tell me fast. Shrinkage limit also we have seen yesterday. What is shrinkage limit? So it is the boundary moisture content between what conditions? This is liquid limit, plastic limit and shrinkage limit. So it is the boundary moisture content between solid and the semi-solid state. And this is liquid. At shrinkage limit, the volume of soil is Vd. Means if you dry the soil beyond shrinkage limit, its volume will become constant, that is Vd. The volume of the soil will not change, that is at shrinkage limit my soil sample is just saturated. At shrinkage limit our soil sample is what? Our soil sample is just saturated. No, this is not actually a crash course. This is not actually a crash course. Not a full crash course, you can say. A small important topics we are covering. Okay, not a complete crash course yet. Anyways, so what I want to say is, at shrinkage limit my soil is just saturated, that is beyond shrinkage limit if you try to dry the soil, its volume will be constant. Its volume will not change and it will go into a partially saturated condition. This will form the basis of calculation of shrinkage limit. This will also form the basis of how the shrinkage limit of soil is calculated. See, one more thing you should understand here. What? A wet soil is dark in color, where a dry soil is lighter in shade. And this change in shade also happens when you dry the soil beyond shrinkage limit. So when you dry the soil beyond shrinkage limits, the color of the soil starts discoloring. It will lose its shade. So it is the boundary water content between solid and semi-solid state. It is the moisture content at which soil is just saturated. That is the minimum water content at which soil could be saturated. When the water content is reduced below shrinkage limit, volume of soil does not change, but the color of soil begins to change. Okay, got my point? Now, how do we calculate the shrinkage limit? For that, we have an interesting test that is known as shrinkage limit test. Now, let me show you the shrinkage limit test in detail. Let's see the shrinkage limit test. what you will do here? See, let us see what you will do here. In the shrinkage limit test, what we will do? First, we will take a soil and we will oversaturate it. We will take a oversaturated soil. We will add water to make a soil paste, but the soil will be oversaturated. And we will measure the volume of the soil. So, we will measure the volume of the soil. Let me call that volume as V1. Okay. We will measure the volume of the soil here. Okay. We will measure the volume of the soil here. This is V1, volume of the soil in the oversaturated condition. Okay. Very good. And we will take the weight also. This is the weight of the soil in oversaturated condition, W1. Now, after that, what you will do? You will dry the soil sample, and after drying, you will again record its weight. The weight is recorded by the weighing scale, and the volume is recorded with the help of mercury displacement method. So again, you will dry the soil, and you will again record its volume Vd as well as Ws. So, what reading you have taken here? What reading you have recorded? So, what record? W1, V1, Ws and Vd. These four readings you have recorded here. These four readings you have recorded here. W1, V1, Ws, Vd. Now, we have to find out shrinkage limit. At shrinkage limit, my soil is just saturated. So, when the soil was drying from oversaturated condition to dry condition, there will be a state at which the soil is just saturated, and water content corresponding to this, water content corresponding to this state is only shrinkage, and this is an imaginary condition. This is an imaginary condition. This will not, this you can't see in reality. The soil will not tell you that now open the gates of oven, I have just saturated. This will not happen in reality. You can either record the oversaturated soil reading or in the dry condition. You know there would be a state at which the soil is just saturated, but you can't have the recordings of reading there. So, that we will have to calculate. How we will calculate? Let us see. So, water content corresponding to this is nothing but the shrinkage limit, that is at shrinkage limit the soil is just saturated. Now, let us try to do this. See, if this is Ws, this will also be Ws and this will also be Ws, my dear friend. I do not know the weight of water here, but what I know is the difference in volume. Here the volume of soil is Vd, here this volume is Vd, understood. So, this volume will be how much? V1 minus Vd, this total volume is V1, so V1 minus Vd. Convert this volume into weight of water, that is V1 minus Vd into gamma W. Phase diagram I have already taught you. Now, we have to find out the weight of water here. How I will find out the weight of water? Very simple. What will be the weight of water in this condition? Here it will be how much? W1 minus Ws. This is this total weight of water minus V1 minus Vd gamma W. This will be the weight of water and it is done. We can easily find out the shrinkage limit. Shrinkage limit is nothing but weight of water by weight of solid, that is W1 minus Ws. Just phase diagram I am using. This is the W1 minus Ws is the total weight of water. From this weight of water, subtract this weight of water, that is minus V1 minus Vd gamma W upon Ws. This is how I can calculate shrinkage limit moisture content. Okay, this is my shrinkage limit moisture content. Okay. Now, using this shrinkage limit data, we can calculate few more parameters. What? We can calculate the GS of the soil as well. Using this data, I can calculate GS also. Shrinkage limit test can also be used to calculate GS of soil solids. How? Let's see. Shrinkage limit test can also be used to calculate GS of soil solids, that is specific gravity of soil solids. How? Let's see. GS is equal to what? That is gamma S upon gamma W. That is weight of solids by volume of solids into gamma W. See, we require this volume of solids. How I can find this volume? Very simple. Can you find out the volume of water here? I can find out. See, this one, this much volume is, this much weight is how much? W1 minus Ws. So, volume of water will be how much? W1 minus Ws upon gamma W. Subtract from this volume, you will get Vs. That's it. So, I can write it here. What? Ws upon V1 minus W1 minus Ws upon gamma W. This is my Vs into gamma W. This is how I can calculate GS using the shrinkage limit. Just V1 minus this volume will give me the volume of solids. Like this we can do it. Very simple. Okay, my dear friends, any doubts till here? So, this is my shrinkage limit test, and this is how we will calculate the shrinkage limit of the soil, and using this test we can find out the what? We can also find out the GS of soil solids. Okay. Let's proceed further now. Let's do one question here, then I will proceed further. Okay. Let's do few questions on this concept. Let's see, let's do this question. Please do this question. Please, my dear friends, do this question. Okay. Do it fast, please. Do this question once, then I will proceed further again. Do this question. Okay. Very interesting question. Try to think about it. Very interesting question. You have to think on the test now. Very good question. Think on it and tell me the final answer. See, A is not the correct answer. What is being said that during the determination of plastic limit of a soil sample using the standard thread rolling method, a soil thread begins to crumble both longitudinally and transversely when the dia of the thread is 3.2 mm. So, when dia of thread is 3.2 mm, we got water content as how much? 24%. Now, try to think what I have said. That for dia equal to 3 mm when the crumbling starts, your water content is plastic limit. But at this water content, you are not able to roll the thread into a dia of 3 mm. It starts to crumble at 3.2 mm dia only. Means your plastic limit should be greater than this. If you have to roll, therefore WP, since D2, yeah, D1, D2. D2 is less than D1. So, if you have to roll the thread into a dia 3 mm, what happened? What you have done is, you have actually you have dried the soil a lot. You have dried the soil beyond plastic limit. है ना? At plastic limit, you can roll the thread into a dia 3 mm, but when the water content is below plastic limit, then you will not be able to roll the thread into a dia 3 mm. So, in that case, you will be able to roll the thread into a thicker dia, that is 3.2 mm. So, if your dia of rolling at which the crumbling starts is less than D1, that is 3.2 mm, this implies what? My plastic limit would be greater than water content, that is 24%. It would be slightly greater than 24%. Got my point? Here what happened is, you have dried the soil more. Therefore, you were not able to roll into a thread of dia 3 mm. So, correct answer is what, my dear? It is slightly greater than 24%. Very interesting question. So, B was the correct answer here, my dear friend. B is the very correct answer. Now, let us do a question on shrinkage limit as well. Try to solve this question, please. Very interesting question. Please try to solve this. Please attempt this as well. Attempt this also. Give me the complete answer, please. Done. Okay. Shrinkage limit is coming out to be 20%. Let me check. No, beta, your answer seems wrong. Void ratio is correct. Void ratio is correct, but your other answers are wrong, I guess. Chalo. Anyways, shrinkage limit is 20.93%. 20.93% is the correct answer. 20.9. Okay, you have given 0.20. Okay, 0.20 seems okay, but 20.93% would be the more accurate answer. Okay, it's okay. Okay, okay. Let's do this question. Let's do very interesting question. See what is being said here. Let's try to solve this question together. We will try to solve it together using the phase diagram. So, oven dry soil of volume of oven dry soil volume means VD is given to me. VD is how much? 225 centimeter cube cc. Okay, has a weight of, and weight of solid is given to me, that is 390 gram. Weight of solid is also given to me. The specific gravity of solid is 2.72. GS is how much? 2.72. And we have to find out the void ratio and shrinkage limit of the soil. Let's try to do the question. We have to find out void ratio as well as shrinkage limit of the soil. See, here we know this is the condition. Solid, air. In dry condition, I will find out the void ratio. So, this is my weight of solid, that is 390 grams. Total volume VD is given to me, that is 225 cc. This is my volume of solids. Vs is how much? Ws upon Gs gamma W, as simple as that. 390 upon 2.72 into 1. Gamma W is 1 gram per cc. Very sorry, voice was not there. Now my voice is there. Okay. My voice is there now. Okay. No worries. Now it's perfectly fine. So, what I was saying is, we know weight of solids. From weight of solids, I have calculated volume of solid, that is Ws by Gs gamma W. Gamma W will be taken as 1 gram per cc. E is Vv by Vs. Vv is Vd minus Vs upon Vs. So, Vd minus Vs upon Vs. How much answer you are getting? That is, I got the answer as 0.569. Now, at Ws, that is at shrinkage limit, soil is just saturated. Use Sevac's formula, that is Es is equal to Wgs, S is equal to 1, W is equal to Ws. Use this formula, that is it. Sevac's formula I am using. So, Ws is equal to E, that is 0.569 into 1 upon 2.72 into 100%. How much answer you are getting? Tell me fast. Like this also you could have solved it. A different way of solving this question, but simple only. We have used the Sevac's formula. 20.91 or 92%. 20.92%. This is my shrinkage limit. Now we have to find out the water content that will fully saturate the soil and cause an increase in volume of 8% of the dry volume. So, let us solve this now. Now, W dash is the water content that will fully saturate the soil and cause an increase in volume by 8% of dry volume. Therefore, W dash will be equal to what? Weight of water will be how much? VV plus 0.08 times VD upon weight of solids. VV is how much? VD minus VS plus 0.08 times VD into gamma W also, na? Because it will be weight of water upon weight of solids. So, VD is how much, my dear friend? VD is 225 cc. Vs is 390 upon 2.72, see, 390 upon 2.72 plus 0.08 times 225. Weight of solids will remain the same, that is 390. Gamma W I will take it as 1. Multiplied by 100, you will get the answer in percentage. How much you are getting? Tell me fast. That is 25.54%. The answer would be how much? 25.5. Very interesting question. Answer is how much? 25.54%. Okay. Now, tomorrow by using these Atterberg limits, we would be seeing the various index properties of soil as well. Okay. Let us meet tomorrow now with the various index properties of soil. So, this is my Telegram channel. You can join with me here and clear all your queries or doubts if you have any. Okay. Thank you everybody. Bye bye.